In section 7.3, we're going to be measuring segments. On page 451, we're going to start with the ruler postulate, which is postulate number 5. So follow along with me. Every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on the line and the real numbers. The real number that corresponds to a point is called the coordinate of the point. So in postulate 5, we have a line with points A, B on that line. Point A is actually, can be, if you look at a ruler, a coordinate of A. And then B is a coordinate of point B. The ruler postulate allows you to measure lengths of segments using a given unit and to find distances between points on a number line. Consider line AB at the right. The distance between points A and B is the absolute value of the difference of their coordinates, or the absolute value of A minus B. This value is also AB, or the length of segment AB. So I'm going to take a pause here and kind of reiterate and make sure you understand the importance of labels. If I told you this, AB, that really is segment AB. This right here represents segment AB. If you just write AB, that means the distance from A to B. So when you actually are talking about lengths of measurement, you would use that, because that represents the distance from A to B. This is segment AB. So make sure you understand the difference when writing different terms, whether or not you have to put a label or not, because it does make a difference. All right, so let's start with our first problem. On page 452, we're going to look at problem 1, measuring segment lengths. And we're going to look at the, got it? What are UV and SV on the number line below? Now this is important that you understand how we're looking at UV and SV. Notice that there's no line, segment symbol, or anything else. So really what it is asking is the distance from U to V and the distance from S to V. So, in the got it problem, what is the distance of UV? Well, we go from 10 to 14. I know that can be a little difficult, but what is the distance from 10 to 14? You subtract 14 minus 10, and that would give you a distance of 4. That's it. That's all you do. The distance from S to V. Now, the distance from S to V, you're going to subtract 14 and negative 4. That is not 14 minus 4. That is 14 minus negative 4. And it's the absolute value. So 14 minus negative 4 would be 14 plus 4. And 14 plus 4 gives you a distance of 18. That's all you do when you measure segment lengths. All postulate 5 says is that every unit of space on a number line represents 1 unit. That's all it says. So it's fairly easy stuff to look at. Even though the problem makes it seem a lot more complicated than it is, that's all it says. Problem number 2, we're going to use postulate 6. Postulate 6 is called the segment addition postulate. Here's what it says. If 3 points, A, B, and C, are all collinear, which means they all lie on the same line, and B is between them, then you know that this segment here, which is segment AB, and this segment here, which is segment BC, if you added these together, if you took AB, now once again, that's not segment, these all represent the distance because there's no label. So the distance AB plus the distance of BC, it's going to give you the total segment distance, which is AC. So this distance here and this distance here, the measurement AB and the measurement BC added together give you the distance AC. So let's look at the got it. So here's the got it. In the diagram, JL, which means the distance or the length of JL, is 120. We want to know what JK and KL would be. Because you have variables and you have expressions, you're going to write yourself an equation. Here's what it says. We know that 4x plus 6 and 7x plus 15 are represented in that picture. Well, we know the entire length is 120. Because our postulate says that each piece added together would give me that length, we are going to write the expression 4x plus 6 plus 7x plus 15. Well, if we add those two expressions together, we know that is going to give us a length of 120, because this piece and this piece added together give me the entire length of 120. So we have just written ourselves an equation. You solve the equation, simplify like terms, you are going to get 11x plus 21 equals 120. Subtract 21 on both sides. 11x equals 99. Divide by 11. The value of x is 9. But we don't want the value of x. We want to actually find the lengths of JK and KL. JK is 4x plus 6. So we take the 9 and plug them into both of these. So 4 times 9 is 36, plus 6, the length of JK would be 42, and KL is 7 times 9, which is 63, plus 15, and that gives us 78 is what I meant. That gives us 78. So our two lengths are 42 and 78. On page 453, we are going to now compare segment lengths. Looking at the gray box in the middle of the page, it says, when numerical expressions have the same value, you say that they are equal. Similarly, if two segments have the same length, then the segments are congruent segments. Notice there's your vocab word. Congruent segments are segments that are equal, same length. So here's what it says in the picture. This means that the distance AB equals the distance CD. AB equals CD. Therefore, segment AB is congruent to segment CD. I really want you to understand the terminology here. If you just say AB and CD, those are equal lengths. Then, if you actually say segment AB and segment CD, that means they are congruent, not equal. They are congruent. And you can look at the picture. If AB is 1 inch and CD is 1 inch, that means they're equal. That means that then segment AB is congruent to segment CD, and you use little tick marks to indicate that. As illustrated above, you can mark segments alike to show that they are congruent. If there is more than one set of congruent segments, you can indicate each set with the same number of marks. So in problem 3, look at the got it. Is segment AB congruent to segment DE? So we look at it, we can see that AB is from -2 to 3. So 3 minus -2 means that that's going to be a distance of 5. And DE is 14 to 10, so that'd be 14 minus 10, that'd be 4. So, no, they are not congruent. Now, part B. Part B says, to find AC, suppose you subtract -2 from 5. Do you get the same result as subtracting 5 from -2? So looking at, on the bottom of page 453, AC, A is at -2, C is at 5. So what it's asking is this. Suppose you subtract -2 from 5. Do you get the same result as subtracting 5 from -2? Well, this gives you 7. This gives you -7. Do you get the same result to find the distance? The answer would be yes. Because remember, the distance, which is from the postulate at the beginning, the distance represents the absolute value. And the absolute value on both are positive. So you would say yes, because you have to take the absolute value of that distance, which makes it a positive. In the middle of the page, on page 454, our next problem is going to start talking about the midpoint. Here's another vocab word. The midpoint of a segment is a point that divides the segment into two congruent segments. Basically, the midpoint cuts a segment in half. A point, line, ray, or other segment that intersects a segment at its midpoint is said to bisect the segment. So if something bisects it, that means it cuts it in half. That point, line, ray, or segment is called the segment bisector. So if something bisects a segment, that something is called the segment bisector. So look at the picture. The picture says we have a segment AC. Here I have a line, and that line L bisects the segment at point B. That makes these two segments equal. AB and BC are equal. They're congruent, so we say that they're congruent. Segment AB is congruent to segment BC. So that means point B, right here, point B is the midpoint of segment AC. And that means L, the line L, is a segment bisector of segment AC. So write this problem down under the got it on problem 4 on page 454. Here's what it says. Q is the midpoint of segment PR. So here's what I want to know. What is the length of PQ? QR and PR. Well, what do we know? Because we know that Q right here is the midpoint, that means it cuts the segment PR in half. Therefore, I know that the expression 6x minus 7 and 5x plus 1 have to be equal. So I can write an equation setting them equal. Now you solve the equation. Subtract 5x on both sides. That gives me 1x minus 7 equals 1. Add 7. You get x equals 8. So I plug in 8 here and here. That means PQ, that would be 6 times 8, which is 48, minus 7, that'd be 41. QR is 5 times 8, which is 40. 40 plus 1 is also 41. Now, wait a minute. Did I really need to do that work? If you did your math correctly, you don't. Because what do we know about these two pieces? They're congruent. So we know that this length of 41 and 41, they have to be the same. So then that means PR, the whole segment, has to give me 82. So there are my 3 lengths. So your vocab review for section 7.3 are these 5 words. Coordinate, distance, and a distance, I want you to understand that when you subtract 2 coordinates, you take the absolute value of your answer. Congruent, know the symbol, and know that when you name segments that are equal, their lengths are equal, you have to say that the segment is congruent to another segment, not equal. Midpoint of a segment is a point that cuts that segment into 2 pieces, 2 equal pieces. And lastly, a segment bisector is a point, line, ray, or segment that cuts another segment in half. So that point, line, or ray, or segment is called a segment bisector.